Welcome to WebRTC Live. In WebRTC Live, we cover the latest technical topics and business use cases for WebRTC and live video. As always, this episode is brought to you by WebRTC.Ventures, leading integrators of WebRTC video into your custom application.
Welcome back to WebRTC Live. I'm your host, Arin Sime, CEO and founder of WebRTC.Ventures. We're a custom design and development firm specializing in building live video applications. You can learn more about us at WebRTC.Ventures. Today, I have as a guest here with me, Dr. Alex. Many of you know Dr. Alex is known very well in the WebRTC world for a number of reasons. A very active member of multiple standards committees around WebRTC. Also popular blog WebRTC.Alex. Interesting post there today, in fact, make sure you check out. And also founder of the WebRTC development firm, CoSMo Software, and founder of the KITE testing framework for WebRTC as well. Today, he's going to talk with us about Real Time AV1. So let's jump right into it. Dr. Alex, thanks for being here today.
Hey, thanks, Arin, for having me, and thanks everybody for joining. Today, I'm going to speak a little bit about Real Time AV1. It's not going to be too technical. I already made a lot of technical talk about AV1 in the past month. They're all online, so if you have questions about that, we can go there. I'm going to speak a little bit more about video over the internet, why AV1 is needed, and then specifically beyond AV1 in general, what is real-time AV1, the real-time flavor of it, right? So I'm going to switch to screen sharing right now. And I'm going to start on the shoulder of giants, which is what everybody should do. There's a lot of people smarter than me out there. Let's start from what they say. The broadcast industry has a different association and committee, and one of them is the Society of Motion Picture and Television Engineers. And so those are people that belong to a lot of companies that have in common to take care about broadcasting, streaming, and television. And they tend to get together and see trends. And in Montreal at the IETF meeting, they came to the IETF, which is the Internet Committee, and say, you know what, digital video is more and more going on IP network. It's not over cable, it's not over proprietary lines with proprietary technology anymore. And for all the segments, right, camera, recording, production, field production, editing, packaging, distribution, all of the above, right? And right now, we're really only using one or a few percent of the internet technology that is available. So we would like to work more together. And that's the broadcast industry coming to the internet people and tell them, we're going to work more together. We're just touching the tip of the iceberg, and we would really want to go deeper and get the best of what you have. And that comes from an industrial association, from an engineer, not an industry association where the company represents the business interests. So that's really a technology trend. Another thing that was interesting at the same meeting in Montreal in July this year was those slides from Akamai, right? That say, okay, this is the problem we have nowadays. So I'm going to shift the problem there and say, well, the key point is this, okay? If you use something like WebRTC, you're streaming from one point to multi-point, right? So it's one direction, it's unicast, as opposed to multicast or CDN approach where you're caching the content across everywhere. So if you take the maximum, the record of Akamai traffic, which was 72 terabytes per second in December 2018, which represent 15 to 30% of the total web traffic. And if you assume that you're streaming 4K with a standard frame rate, then you're going to use 40 megabytes per second, which means you can only have 1.8 million simultaneous viewer to that kind of thing to reach the existing record, right? So, easy. Is it easy or is it difficult? Do we have a problem or not? So if you look at actually the audience for the most viewed movies, you realize that you reach 1.8 million, the maximum capacity reached to date, with the 200th movie called The Resident. And I'm really challenging anybody here to remember what The Resident is as a movie, right? So that means you're going to have a problem. It's not going to work. You have already more than 200 titles in 2017 that were getting an audience of more than 1.8 million viewers. So with the current technology sets, and we're speaking about July 2019, right? So this year, it's not going to work. So something has to give. And this is 2 million viewers is a small number, because if you compare to the FIFA World Cup final, it was not streamed over the internet, of course, over cable TV, but it had a 500 million audience. The Cricket World Cup, 200 to 300. The Super Bowl, 100 million. And if you look at the people over the public internet, like Twitch had a record in June 2018 of around 3 million, and the World Cup 2018, around 10 million, right? So those are the numbers you have to keep in mind today. So if you were to do naive WebRTC today with a normal 4K and so on, you will break the internet. You will go over capacity very, very, very easily, right? So the same meeting again, and I love that meeting, we had some feedback from Justin Huberty at Google, one of the technical father of WebRTC, but also doing other stuff, about Project Stadia, right? And saying, if you look at the current video streaming landscape, you have the high latency, the original HLS, you have standard latency, better HLS, ultra low latency, HLS with CMAF, and then you have things that are less than 1 second. And there, you only have WebRTC, right? So depending on the latency target, you're gonna choose one or the other. The typical video streaming like Netflix, YouTube, HBO Now, which still represent 99% of the video traffic over the internet, is totally okay with multi-second latency. Right? You don't care if that movie is late because it's not happening live, and as long as you buffer first, and that gives you time to prepare your cocktail, the chips, and get comfortable on your sofa, you're good. But if you want interactive video streaming like HQ Trivia, like Twitch, like Stadia, you cannot afford latency, right? So you have a latency problem that forces you to use technology that are using more bandwidth, and then you make the bandwidth problem even worse, right? So how do you deal in part with that? So one way to deal with that is to have a better codec. So AV1 was created by the Alliance for Open Media in order to get a next generation codec. So the focus of a codec is always the same, compression rate, right? Or compression quality ratio. You need to be able to get the same quality for less bandwidth usage or less storage usage, and you need to have a better quality for the same bandwidth. If you put it that way, really the Netflix problem is simple. The average data plan in the US is 4 GB per month. How many hours of 1080p video can I stream within these 4 GB budget, right? And so it's really for everything that is video on demand, the problem is really just the compression quality of the codec. But for people that do real time, it's a little bit different because you need to take into account the latency. And that brings you to some problem. Usually when you have media streaming, again, Netflix or YouTube, you prepare the media, you encode it, you send it to Twitch, YouTube Live, Facebook Live, whatever they want. They process it there, they upload it somewhere, and then they serve it later on, right? And usually you use Flash to stream in, and they use HLS for the distribution. That includes too much delay and too many problems. There's too many buffers here and there. So WebRTC end-to-end provide a solution with much less latency. But that means that all the technology that were here in the blue part, in the infrastructure of a normal or usual or legacy video CDN, cannot be used anymore. You cannot afford to re-encode on the cloud. You cannot afford to change the format. You cannot afford to store on disk even. Everything needs to be on the wire and on the fly. Otherwise, you're not interactive anymore. So if you look at the history of AV1 with a focus on the real-time event, so that's very simplified, in the past 2 years, it's been super, super fast. The original AV1 codec specification, only the codec, was announced in March 2018. And so as soon as that was done, two things could start. People could start adding, well, three things. People start adding it in their services. So Netflix, I heard from Google that 70% of the video over 1080p that are served today on YouTube are served with AV1. So it's already in production, even though nobody really realizes it, right? So people start adding it in their services. Other companies start preparing some hardware acceleration, some specific chips, some specific setup boxes, anything that can make it faster and easier to encode and decode. And a third little group, the real-time group within the AO Media, start working on how can I put AV1 in RTP and then WebRTC. So in October 2018, for Halloween exactly, we announced the first AV1 integration in RTP and WebRTC. It was 2 frame per second. It didn't support SVC, but it was already fun. A lot of things happened. We joined AO Media officially. Intel and Netflix announced their own collaboration around the SVT AV1 codec, which is a great codec for different use cases, and so on and so forth. What's interesting, in May and June 2019, we had the first chipset. So you have the first mass production, not FPGA, chipset that allows AV1 decoding up to 8K and the corresponding setup box. So that's really where the adoption by some of the biggest players is starting, right? In June as well, Cisco demoed the first real-time AV1 integration in RTP and WebRTC in WebEx. It's not open source. It didn't support SVC, but it was real-time, and it had already a huge compression advantage over what WebEx was serving before. A few weeks later, for ComCon UK, we released our own demo of real-time AV1 in RTP and WebRTC for streaming this time. So WebEx is more communication with its streaming, almost the same implementation in the WebRTC stack. We pledged to open source it, which we are in the process of doing, and it didn't have SVC at the time, but now it has, right? So a lot of things happen. What's interesting is what does that mean, real-time AV1? Once you have the codec, why can you just use it right away and put it in WebRTC? Well, the problem is there is an extra layer when you do real-time, and that's the real-time protocol. In the usual streaming, it's file-based and it's HTTP-based. So once you have the codec done, you just dump it in the file, you chunk the file, and then you're done. You just push the chunk. But in real time, you need a feedback-based mechanism. And the only one that is used for all the real time, whether it's unified communication or streaming or anything else really nowadays, is RTP. So you need to say, okay, now I don't have a hard disk that can contain my entire movie. And actually, I don't want that because I need to push the frame as they arrive to be real time. I need to cut my frames into payloads that can fit into an RTP packet, right? That's the first problem. So mapping the chunk in AV1 bit stream called OBUs with an RTP packet while staying in a limited size budget was the first problem. This is relatively easy. You can actually do it smarter. You can remove part of the bit stream. Okay, that the part that says this frame is finished and I'm starting a new frame, you can align those with the RTP packet, and then you don't need to put that in the payload, right? So you can do a few optimization there. But the real key is to enable SVC. So SVC is the key to enabling this, to enabling not having to transcode on the server side to adapt to the bandwidth. So the main advantage of AV1 beyond the compression ratio, the better compression ratio, is the capacity to support SVC by default. It's the first codec in the world that has SVC bundled in by default, where H.265, H.264, VP8, VP9 had an SVC mode and an annex of the specification, but it was not on by default. So you can directly get the compression advantage and the real-time advantage there. So I'm not going to go into the difficult part, the optimization to be a better bandwidth citizen by Google, helping the decoder, helping the SFU decode faster. so to be faster at dropping the packet to change resolution. I think I'm going to stop there for the hardcore, and I'm going to spend the few minutes left on the impact on the platform. So if you have a platform, be it a streaming platform or a video conferencing platform, the thing you're going to get from a real-time AV1 SVC is a higher compression rate. It's going to be SVC, which allows you to reduce the latency and not transcode on the server side and change resolution within 10 milliseconds, right? So you can adapt very, very quickly. You don't need to wait for an iframe. You don't need to wait until a few seconds for the buffer to be empty to be able to change the resolution and start another stream. No. You directly go there from one packet to the next. The only problem that can arise is that it's going to use a little bit more CPU on the sender side and on the receiving side. So on the sender side usually is not a problem in the streaming industry because people have studio-like or gaming-like PCs that are powerful enough. Whereas in the video conferencing, sometimes people have a very underspec laptop with a crappy hotel Wi-Fi. It doesn't work. But so if you want to maintain the low latency and the real-time aspect everywhere, you need to be real-time for all the other features. So you need to be real-time for the content protection. You need to be real-time for the server-side ad insertion. You need to be real-time for the on-demand adaptive bandwidth, and so on and so forth. That has a lot of side effects. And so people need to be aware that adopting a codec like AV1 or SVC is not something that is done very quickly. It should be done in phases. And what I suggest is for people to start with VP9 SVC, for example, look at the impact, and then when they're ready with that, they can go to AV1. So timeline, AV1 should be, where can I stop the screen sharing? Boom. AV1 should be in Chrome around, in Chrome WebRTC. It's already in Chrome for the decoding, around Q1. And then there will be an intensive period of testing, we think 2 to 3 months. There is 28 different modes that we need to test and check if we can pass from one to the other and back and so on and so forth with different SFUs. So we're going to try to work with different open source SFUs and closed source if they want to make sure that this thing is really tested in all the possible corners, because that will be the part that is going to be difficult for the adoption of AV1 in WebRTC. And that's about.
All right, thank you. Thank you, Dr. Alex. Appreciate it. Appreciate the overview. As you mentioned, there are the IIT RTC conference that you just recently spoke at. They just published videos of the talks there, including yours, and I know you're regularly on the speaking circuit, so take a look at some of Dr. Alex's other talks on AV1 to go into a little bit more detail on there. For those watching this live, if you have any questions, feel free to drop those in the chat right now. And while we give people a chance to do that, a couple of questions quickly for you, Dr. Alex. Actually, we have a question here from Alberto. Does using the AV1 SVC, would that require the SFUs to have a more powerful CPU as well?
No, I don't think so. I think actually it's going to simplify the SFU logic. When you deal with SVC as opposed to simulcast, the logic is simplified and it's much faster because you don't have to look for iframe. You don't have to keep a buffer of one stream. When you change stream, it's complicated. And if you don't have simulcast and SVC, then you need to transcode. So you don't have an SFU, you have an MCU. So it's likely that people will go from MCU to SFU with simulcast and then eventually with SVC, and they're going to see only improvement of the quality. You can switch resolution when the bandwidth is going down much faster and come back much faster as well when the bandwidth goes back to the original level. And the logic for the implementer inside the SFU is also simplified.
Okay. So the extra CPU processing is all on the sender side, essentially.
Correct.
AV1.
Correct. And of course, on the decoding side, but usually the decoding is simpler. Not everybody on the viewing side will receive the higher resolution, right? So,
right, makes sense. And that extra cost in CPU, as I understand it, correct me if I'm wrong, that's primarily because AV1 is a 2-pass codec. Is that the extra work that's being done, or?
So all the codecs are 2-pass codec if you want low latency. If you aim for a very high quality, you do 2 passes. But when you're real time, you don't even do one pass. You only do 1 frame per 1 frame. You take 1 frame, you encode it, you push it. So depending on your implementation, SVT AV1 does not have a real time mode yet, but LibAOM has a real time mode. So you're not achieving the same compression factor than the 2-pass mode does, but you can do 30 plus FPS in real time on a MacBook.
Right. Okay, that makes sense. Thank you. So we mentioned briefly at the beginning of our conversation, you've got a new blog post up today on WebRTC.Alex. And one of the things that mentions is that the WebRTC working group is currently scheduled to close in April of 2020. And you also mentioned to me in our pre-show conversation the term WebRTC in general, and with WebRTC new version, the term WebRTC may be going away a little bit. So take a minute or two and tell us a little bit about what you see kind of coming in that future, both terminology and from the standards group's perspective.
Right. I think the WebRTC has been a difficult, like any disruptive technology, has been difficult to come through. And especially at the beginning, there was a codec war. There was a lot of people with different objectives trying to get together. That was difficult. And as a result of that, when some people hear WebRTC, they have a mixed feeling and they say, well, it sounds complicated. It sounds like a lot of drama. Maybe I don't want to be associated with that. And that's not the case anymore, right? Too much. So, I mean, WebRTC is pretty stable. The IETF part, which is the bottom of the stack, has been done, and the working group at IETF closed last year. The WebRTC, so the JavaScript API, is going to be closed this year. We have more than 50% of the tests that pass on all the 4 major browsers. I mean, the situation is good. Now, what about next, right? Some people want to use a better media transport, quick, especially for AR, VR, and 360. There will be some advantages there because the data channel is maybe going to be better synchronized with the media, which is not the case so much with the data channel right now in WebRTC. People want to use AV1, new codec. People want to do end-to-end encryption. All of those are funny hats, mustache, it's November, whatever your poison is, right? And all those use cases that are beyond the original scope of WebRTC, which was multi-party gaming or video conference, need to be addressed by the web, but it doesn't need to be in a WebRTC group. So since we're seeing a convergence between the traditional media, broadcast, television, digital media in general, and the real time, a lot of this work has been transferred to the media group, right? So the media group traditionally was dealing with the YouTube thing, right? So getting video streamed in and playing it. So the video tag, the audio tag, they kind of depend on the media group. They handle the DRM and things like that. So now, web codec, which is the capacity to bring your own codec, for example, written in WebAssembly, whatever you want, right? So have access to the raw frame and be able to produce an encoded frame and re-inject the encoded frame into the WebRTC stack. Web codec, that new name, will be one of the deliverable of the media working group. And then there is another one, which is web transport, which is how do I do media over quick, right? Or over something else than RTP. And that has been called web transport. It's a little bit more complicated than just over quick. It can be over other stuff. And this is looking for home right now. So it's not sure whether it's going to happen at the IETF. because it's touching the transport. RTP traditionally was standardized at the IETF. So should it be there? Or in the web, or both, just like WebRTC? So this is still an ongoing question for web transport.
Okay, great. All right. Well, thank you very much, Dr. Alex. We're coming to the end of our time here. Do you have any announcements or anything that you want to pass along to our viewers before we close?
So next week is IETF in Singapore. So we're going to have a hackathon this weekend where there is a lot of things interesting on the table. We're trying to bring H.265 support to WebRTC and things like that. So stay tuned. There will be some news. I have also a blog post with all the AV1 presentation that I've done that is pending, and that should go out next week. So the RTC presentation, the NAB in New York, the AO Media Symposium, and so on and so forth. So people that are more interested in AV1 and want to go more into the details, follow that blog post and do not hesitate to ask questions in the comments there.
Perfect. All right. Well, we'll look for that on the WebRTC by Dr. Alex blog, and you can keep up to date also with Dr. Alex at CoSMo Software. And so, Dr. Alex, thank you again for joining us today. Really appreciate your time, and best of luck to you in your continued travels around all of this. And thanks for all of the blogging and that you do around to keep us all informed on this work. We really appreciate it.
Thank you.
All right. So thank you to all of you for joining us for another episode of WebRTC Live. In addition to watching the rebroadcast of this on Crowdcast, we'll be posting this to WebRTCVentures and YouTube next week. And you can subscribe to us on Crowdcast or on the WebRTC Ventures blog to find out about upcoming episodes. So thanks again for your time, and let's make it live.
Thanks for joining us for WebRTC Live. Visit our website at WebRTC.Ventures to learn more about our custom design and development services, and to learn more about upcoming episodes of WebRTC Live.